grouping. So clustering basically refers to the grouping of records or observations, or you can say cases. Okay, so into different types of classes. Okay, so classes means in a class you will be keeping different types of similar objects. Okay. One of the best example of clustering is your email filtering. Okay, so we are using that one. Means that type of algorithms are used in our uh, email filtering programming. Okay, so suppose there are some spam are there and some other things are there, so they are filtered and categorized, and those are placed in that sections. Okay, same thing means so that is one of the best example of clustering, uh, which we are experiencing all the time. Okay, so clustering, what happens? A cluster is a collection of records that are similar to one another and dissimilar to the records in other clusters. Okay, so basically you will be means you will be given with a set of records or data. Okay, so many data points will be there. Okay, will be categorizing, or you can say will be classifying into different parts or different class based upon their properties. Okay, based upon their similarity. Okay, so I'll be telling you what are the techniques of putting them into different clusters. Okay, so based upon some of the characteristics, or you can say some similarity between the objects, will be putting them into different groups. Okay, so that is basically one type of grouping problem. Okay, so here we may classify that into two groups. We may classify that into we may group them into two groups, or we may put them into multiple groups also. Okay, but one thing we often use the term with your clustering, that is your classification. Okay, so uh, what happens? Classification is one of the term, or you can say literary term, which we often use with your clustering, but there are some difference. Okay, so in classification there are some target variables. Okay, but in clustering there are no target variables. Okay, so that is the most important thing you should understand, or what is the basic difference between your clustering and your classification. So clustering differs from classification in that there is no target variable for clustering. Okay, so so in classification there may be some target variable based upon which we will be classifying the things. Okay, there will be some guiding thing, we can say, or there may be some values given to us, or there may be some uh, predefined criteria based upon which we will be classifying the things. But in clustering there is nothing will be given. We will be using, or will be choosing some of the criteria based upon the data set, and based upon their similarity or dissimilarity, we will be putting them, or will be gathering them, not gathering, we will be just splitting them into different categories. Okay, so that's the main difference, that in classification there will be some target variable. Okay, so this is very, very important, because this target variable is basically used for your, or used to define your supervised and unsupervised learning process. Okay, so basically in clustering there is no target variable, so that's why this is one type of unsupervised learning process. Okay, or unsupervised algorithm. Okay, you will feel that whenever I'll be discussing one example, you will understand that why I'm saying that this is unsupervised. Because you might have seen in your regression model there will be some set of points given, and from that set of points we will be choosing 70% of the data, or you can say 80% of the data as your training and testing purpose. Okay, so a part of the data is used for training and rest of the data is used for testing purpose. Okay, but here otherwise you can completely use the set also, but in this case nothing will be given. We'll be choosing the set, and based upon that we'll be starting categorizing them into different parts. Okay, the clustering task does not try to classify, estimate, or predict the value of a target variable. So what happens here, as no target variables are there, we are not going to work according to that target variable, or based upon some criteria we are not going to deal the problem. Okay, so there are no uh, we can say that we are not means the problem is not based upon any criteria. Okay, so or is not based upon any type of target variable. So we are not doing these types of classification or estimation or prediction based upon some target variable. Okay, so we'll be classifying the things or estimating the things based upon the characteristics which we observe from the data itself. Okay, so what happens, the set of the data will be given to us and we'll be looking at the data, and based upon their similarity, whatever we are feeling correct, after that we'll be starting using these types of algorithm to categorizing them into different parts. Okay. Instead, clustering algorithms seek to segment the entire data set into relatively homogeneous subgroups or clusters. Okay, so these are some of the things. So cluster means they are your homogeneous subgroups. Okay, means the data points, or you can say the data which are there in a cluster, they have homogeneous property. They are quite similar to each other. Okay, where the similarity of records within the cluster is maximized and the similarity of records outside this cluster is minimized. Okay, so what happens whenever we are putting some of the data into a cluster, we try to maximize the similarity between the this data. Okay, so based upon that similarity, we are going to put them into a cluster. Okay, and those who are not similar, we are putting them in some other clusters. Okay, so that is the process. You will better understand this after when I'll be discussing the example. Okay, a very good example I have prepared. So from that it will be very clear how this clustering algorithm works. Okay, so that's the thing that uh, the entire data is means we are going to split the data into different categories or different segments, and each of these segments will be called as your clusters, will be called as your clusters, and whatever points we are going to keep in that clusters, they will be having some homogeneous property, or they will be having similar properties. Okay, and the dissimilar things are going to be kept in some other clusters. Okay, so another example I can also say that suppose you might have seen different types of things are given to us to classify. Okay, so suppose different types of flowers are given to us. Okay, suppose in a basket different types of flowers are given. Okay, there may be lily, there may be zinnia, there may be there may be your rose. Different types of flowers may be given to us. So suppose we need to classify them, or we need to split these flowers, then what happens, we will be splitting the flowers based upon their criteria. Okay, suppose there are some red color flowers, then we can keep them one side. Blue color flowers, we can keep them on side. So these red color flowers will be forming one cluster. The yellow color flower, they will be forming second cluster. The blue color flower, they will be forming different cluster. So like that, we'll be splitting, or we'll be putting the flowers in different clusters based upon the colors. Okay, so that is one example. Based upon the color, we are categorizing the thing. But this is the thing, or the process is very easy whenever we are directly uh, uh, when we are directly dealing with the flowers or different types of objects. But the problem becomes complex when we go for computer programming. So that's why what happens, we need to choose different parameters. Okay, we need to put all these things, or whatever physical objects are there, we need to put them into two-dimensional objects, or you can say three-dimensional space, or you can say multi-dimensional space. Okay, so based upon that distance, we will be trying to figure out their similarity property, or you can say similarity index. Okay, so you'll understand that after explaining this example. So this is the algorithm of your so first uh, under your under your clustering, there are so many types of algorithms are there. Okay, but one of the basic, or it is a straightforward algorithm, is your k-means algorithm. Okay, so first we'll be discussing this k-means algorithm. After that, we'll be going to some hierarchical algorithm. Okay, so next class we'll be discussing that. First, we'll be discussing this k-means algorithm today. Okay, so what happens in this case? So This is the algorithm. Okay, so this consists of 5 steps. You can just step 1, step 2, step 3, step 4, step 5. Okay, so K-means clustering algorithm is straightforward and effective algorithm for finding clusters in data. Okay, first step is to ask the user how many clusters means K indicates the number of clusters into which we want to partition the data, entire data. Okay, how many clusters the data set should be partitioned into. Okay, first this should be decided. Okay, whether 2 clusters will be there or 3 clusters will be there, first that should be decided. Okay, next, randomly assign K records to be the initial cluster center locations. Okay, so after that, once your K number of or the K is decided or the number of clusters are decided, after that we'll be choosing the cluster centers. Okay, so this is chosen randomly. Okay, next, for each record, find the nearest cluster center. Okay, thus in a sense, each cluster center owns a subset of records, thereby representing a partition of the dataset. So after choosing this cluster center, we'll be trying to figure out the distance between different points. I'll discuss that. It will be clear up when I'll be discussing the example. But for the time being, you just try to imagine what are the things those are going to happen. So these are the three cluster centers. Suppose I'm taking k is equals to 3. Okay. Suppose I'm taking k is equals to 3. Then these are the 3 cluster centers. Then suppose this is the initial set of data. So based upon these 3 cluster center, I'll be trying to find out the distance between these points. Okay. And based upon this distance, I'll be uh, I'll be partitioning this dataset into 3 clusters. Okay, 3 clusters means those clusters will be based upon or they will be having the centers as I have chosen in the previous step. Okay, so like that. Okay, so here it will be one cluster, here it will be another cluster, here it will be another cluster. So in these 3 clusters, I am going to put all this data set. Okay, based upon the distance. Okay. So once this test task has been completed, after that I am going to update my cluster center because whatever cluster center I have chosen in the initial state, those are randomly chosen. Okay, so here I'll be modifying those cluster center. Okay, so that thing is written for each of the K clusters, find the cluster centroid. So how I am going to update this cluster center? I'll be finding out the centroid of this cluster. So that will be our new cluster center. Okay. Update the location of each cluster center to the new value of the center. So what was the previous the previous cluster center is going to be replaced by our new cluster center, which is the centroid of our cluster. So that is the process we are going to follow. Next, repeat the step 3 to 5 until convergence or termination. Okay, so this thing is going to be repeated, means these 3, 4, 5, actually these 2 steps are going to be repeated until our algorithm converges. Okay, so convergence means until there is no change in the result. Okay, I will tell you what happened exactly in this algorithm in this uh, so it will be very much clear whenever I'll be discussing the example. Okay, so I'll be coming to this process once again, this algorithm once again after discussing that example. So the thing is that how I'm going to calculate the how I'm going to calculate all those things. Okay, first I'll be discuss. Okay, let us discuss the example. After that, I'll be coming to this part. Okay, so that will be better, I think. Okay, let me discuss the example first. Okay, so these are some of the fundamental things written on this uh, written here. Okay, so first is your I have already told you that K means clustering algorithm is one type of unsupervised algorithm. Okay, so the first step is to we'll be deciding the K, the number of clusters uh, in which we are going to partition all the data. Okay. So before I go into the problem, there are some fundamental things. how to measure the similarity between two clusters. Okay, so there are four techniques used to find or the measure the similarity between clusters. Suppose this is my cluster 1, this is my cluster 2. In my cluster 1, 3 points are there, like your 1 2 3, you can see. In your cluster 2, 3 points are there, 4 5 6. One of the distance that is called as your single linkage distance, that is denoted by D34. So this is the nearest distance between the two clusters. Okay, you can see the distance between point 3 to 4 is the nearest distance between the two clusters. So that is called as your single linkage distance. Okay, similarly, if you are calculating the distance from 1 to 6, okay, so that is called as your complete linkage distance. Okay, that means this is the farthest distance or the maximum distance between the two clusters. Okay, so all these distance values, or you can say similarity things, are calculated based upon the distance between different cluster points. Okay, next, average linkage distance. Okay, average linkage distance is something, as the name suggests, that average. Then what happens here, we will be taking or we will be calculating all possible distance between the cluster points, and after that we will be taking the average of them. Okay, so basically what happens here, suppose we are considering point 1 here, then first we'll be calculating D124, D15, D16. Okay, this is one set. Secondly, D24, D25, do D26. This is second set. Okay, D34, D35, D36. This is third set. Okay, so these are the all possible distances between two clusters. I'll be taking the sum of all these distances and I'll be taking the average by dividing that with 9. Okay, because you can say 3 into 3, that is equals to 9. So that will give us one type of similarity between two clusters, that is called as your average linkage distance. Okay, similarly, if we are finding out the distance of the centroid of these two clusters, that is called as an average group linkage distance. Okay, means suppose here 3 points are there, C1 is the centroid of that point 1, 2 and 3. Okay, so this is the centroid of these 3 points. Okay, similarly C2 is the centroid of point uh, 4, 5 and 6. Okay, and whatever distance I am calculating, that is called as your average group linkage distance. So these types of four, or you can say these four parameters, or you can say these four types of distance are used for measuring the similarity between the clusters. Okay, remember that, measuring the similarity between the clusters. Okay, or you can say distance between the clusters. Okay, next thing, another two types of parameters are there which are used to find out the distance between two observations, or you can say two cluster points. Okay, suppose you can see, suppose I want to find out the distance between point 2 and point 3. Okay, sometimes these points are also called as your observations. Okay, you should understand that the naming is uh, observations. These are also called as your observations. Okay, suppose I want to find out the distance between point 2 and point 3, or you can say observation point 2 and point 3. Then two types of things, or two types of means usually two types of definitions are used. First is your Euclidean distance. Okay, so here what happens, one observation is u, which is denoted by your u1, u2. These are the coordinates. Okay, so this is basically a multi-dimensional point. Okay, u1, u2, u3 up to u q is there. Okay, similarly, v is your second observation point. uh, it has some coordinates like v1, v2, v3, vq are there. So Euclidean distance is simply uh, square root of u1 minus v1 square plus u2 minus v2 square plus uq means up to uq minus vq whole square. Okay, so this is the Euclidean distance. This formula you have studied in your plus 2, means distance between two points. Okay, on two dimensional points. Similar type of means similar formula is there. This is for n dimensional thing or multi-dimensional. This is one of the common formula that is used to calculate the distance between different cluster points or observations. Okay, this must be noted that cluster points or observations. Similarly, sometimes we may use this definition like a rectilinear distance for programming purpose. Okay, so usually to avoid the square and root over calculations, we use these types of definitions in programming purpose. So what happens if I want to find out the rectilinear distance, then what happens? The distance will be simply u1 minus v1 mod or modulus plus u2 minus v2 modulus plus up to uq minus pq modulus. Okay, so just we have to find out the absolute distance and take the sum of them. Okay, so basically you can see uh, uh, to avoid the squaring of these terms and taking the square root, we are simply adding this absolute distance. Okay, so sometimes in programming this technique is also used. Okay, but what happens, it has less accuracy as compared to your Euclidean distance, because Euclidean distance gives us the exact distance between 2 points, whereas this doesn't give that much accurate result. But definitely the time consumption of this process is very less as compared to this one. Okay, so now these are the fundamental things which will be used for finding out of for finding out the distance or similarity between points. Okay, so first thing, let me remind you, these are the four techniques or four ways of finding out the similarity between two clusters, and this is the these are the two ways to find out the distance between two observations, or you can say two cluster points, or simply 2 points. Okay, so next go to the let's go to the k-means clustering algorithm. Okay, so suppose there are 8 points are given. Okay, this is one example. Suppose 8 points are given, like a1 uh, 2 comma 10, a2 2 comma 5, a3 8 comma 4, a4 5 comma 8, and a5 7 comma 5, a6 6 comma 4, a7 1 comma 2, like that. Okay, so I need to split these whole 8 points into three different clusters. Okay, this is the question. Okay, I need to split them into three clusters. Okay, three clusters means I need to put them into three parts based upon their similarity, or based upon their closeness, I can say. Okay, the points which are close to each other or nearer to each other, they will be kept in one cluster, like that. Okay, and I'll be putting them into three different clusters. Okay, so here k is equals to 3. K is equals to 3. If it is asked to you that just put them into two clusters, then k will be equals to 2. Okay, but here in this question it is given that the k is equals to 3. Okay, so that thing will be given in your question, or that will be given in your problem, that you have to partition the whole data into two clusters or three clusters or five clusters. Okay, so based upon that, you will be finding out the k. Okay, so once your k is decided, next task is to find out the cluster center. So whenever I am trying to find out the cluster center, okay, so first is to find out your k. Second step is to find out your cluster center. Okay, so whenever I am trying to find out your cluster center, there is no specific technique available. Okay, so you can take any 3 points as your cluster center. Okay, so any 3 points means you can choose arbitrary points like 0 0 0 0 0 1 1, any point you can take, or you can choose 3 points from this data set itself. Okay, usually people use three data set for 3 points from this data set to reduce the calculation. Okay, otherwise you can choose any 3 points. Okay, arbitrary points. Okay, like that point may not maybe in this data set or may not be. Okay, that doesn't matter. Okay, but usually choose three data points from these choose three cluster centers from this data set. Okay, so here what happens, my initial clusters I have taken as your this one 2 comma 10, second as your a4. Okay, and a7. Okay, this one 2 comma 10, this is my first initial cluster. 5 comma 8, second initial cluster center, and a7 1 comma 2, that is your third cluster center. I have just chosen like that. You can choose any value. Okay, you can also choose 8 with this A8 also. You can choose A3, anything you can choose. Otherwise, you can choose any data point which is not inside this data set. Okay. But remember that if you are choosing the data cluster centers from this data point, then one or two calculations will be reduced. Okay, I'll tell you how that is happening. Okay, and another thing, whenever you are choosing the cluster centers among this data set, try to try to select the cluster centers which are far apart from each other. Okay, so that will actually reduce your iterations, number of calculations. Okay. So here I have chosen the these three data set that data points as your cluster center. So here I'll be starting my calculations. Okay. So what happens? You can see on this, I have just formed a table here. Okay. So on this column, you can see all the data points I have written. So A1, A2, A3. Please look at these things carefully. Okay. A1, A2, A3, A4, A5, A6, A7, A8. All the data points I have written here. And here, three cluster centers I have written. Okay. C1, that is equals to. Okay. C1 is equals to 2, 10. This is your second cluster center. 5, 8. This is your third cluster center. Okay. So here what happens? I'll be trying to find out the distance between these cluster centers with respect to different points. Okay. So first I have to find out the distance between this and this. Okay. So what is the distance between A1 to this cluster center? We can say this is 2, 10 is there. Here same point is there. So the distance will be 0. Okay. Next, what is the distance between A1 to CU2? So the distance will be, I have to find out using your Euclidean formula. So Euclidean formula is distance means you have to use this one. Okay, U1 minus B1 whole square plus U2 minus B2 whole square. Okay, so that using that formula, I have to calculate the distance. Okay, so here what happens? 5 minus 2 whole square, that is equals to 3 whole square. Okay, 5 minus 2 whole square, 3 square. 8 minus 10, that is equals to 2 square root over. Okay, so that is equals to root over of 9 plus 4, that is equals to root over of 13. Okay, so root over of 13 is equals to 3.6. Okay. Similarly, next I have to find out the distance between these 2 points. Distance between 210 to 12, that is equals to 8.06. Use same formula. Okay, Euclidean distance. I'm writing down here. Euclidean distance. Okay, so all the calculations have been done based upon this Euclidean distance. So here nothing is there, just you have to find out the Euclidean distance. Okay, similarly, second calculation or second row, what happens? We are going to find out the distance between A2 to C1, means we will be finding out this distance and this distance. So distance between 25 to 210 is equals to 5. You can see that 2 to 2 that becomes your 0 and 5 to 10 that becomes your 5. Okay. Next will be this is your 4.24, that is your 3.6 3.16. Like that I have to find out all the distance. Okay, so all the possible distance means basically we are finding out the distance between the data points or the cluster points with respect to their cluster centers. Means here I have chosen these 3 points as my initial cluster center. Okay, so once I have found out this distance, after that I am going to assign the data points or these data points to different clusters. Okay, so here you can see in these three distance, which is the minimum, I have to find out that one. So here you can say the distance is minimum here. Okay, that is equal to 0. So this is your C1 or first cluster. So this data point will be allocated, or that is going to be kept in first cluster. So that's why I have written here this must be kept in your C1 or cluster 1. Similarly, here in this row, you can see the distance minimum is this one, 3.16. So that's why this data point must be kept in your third cluster, C3. Similarly, here you can see the minimum distance is this one, 5. So that's why this data point must be kept in your second cluster. Similarly, here you can see 0 is there. So that must be kept in your second cluster. Similarly, here also you can see in this row, 3.6 is the minimum. So that's why it should be kept in your second cluster. here you can see same 4.12 is here. This is the minimum one. So that's why this data point should be kept in our second cluster. Similarly, here 0 is there. So that's why it should be kept in your third cluster. Okay. Similarly, A8 is there. So here, 1.41 is here. This is the minimum one. So this point is going to be kept in our second cluster. So once I have assigned the clusters to, or I kept all the points in the cluster, let's see what happens. Okay. So these are the data points. You can see this is your A1, this is your A2, this is your this is your A3, this is your A4, this is your A5. Okay. So these are simple coordinates. You can see that one. Okay. So you can see here in this axis 1, 2, 3, 4 is written, and in this axis 1, 2, 3, 4 like that. Okay. Uh, I'm just locating all these points. So the A1 you can see 210 is there. So 2 means in this axis 2 and 10 means in this axis 10 steps. So that is your A1 point. Okay. And similarly A2 you can see A2 is here. Here is your A2. Uh, this is your A2. Okay, so A2 you can see here. So A2 is your 2,5. So 2,5 like that. I have located all the points. And after first step of your clustering, you can see your A1 comes under your cluster 1. So that's why you can see this is one cluster. Okay, because no other points are there in your cluster 1. So that's why I have just rounded this one as by one cluster. And you can see this A2 and your A7, these 2 points are in your cluster 3. Okay, so that's why you can see A2 and A7, they are grouped in one cluster here. Okay, and rest of the points you can see, rest of the data points like your A3, A4, A5, A6 and your A8, they are under your cluster 2. So that's why I have grouped them in another cluster, that is your cluster 2. Okay, so here you can see based means based upon their closeness, or how they are close to each other, based upon that they are grouped in different or 3 different groups. Okay, so this is your one group, this is your second group, this is your third group. But here what happens, here you can find out there may be some other possibilities also. Okay, here you might be thinking that this point may also be kept in this first cluster, means this A8 should not be, or it's not good to be kept in this cluster. Okay, so means from direct visualization we can understand that these 2 points may be kept in these clusters. Okay, like that anything can happen. Okay, so that's why this algorithm is not complete right now. So we have to again move to second step. So what is the second step? We have to modify the cluster center. So previously what happened, we have taken or arbitrarily chosen the cluster centers, and here we'll be finding out the new cluster centers. So what is your new cluster centers? So new cluster center will be average, or you can say the centroid of these cluster points. Okay, so here you can see in your this cluster only one point is there, so that will be your new cluster center. Okay, but in this case for this cluster you can see 5 data points are there, so the cluster center will be the centroid of all these things. So that's why you can see the new cluster center I have calculated that means I have to just use this formula x1 plus x2 up to xn by n, and your y1 plus y2 plus y3 up to yn by n. Okay, by using this averaging formula, I'll be finding out the centroid of these clusters, which will be taken as your cluster center. Okay, so here you can see this is the value of your, or you can say the updated or new cluster center, 8 plus 5 plus 7 plus 6 plus 4 by 5. Okay, this is the cluster center of this one. Okay, means x coordinate of this one and y coordinate is this one. So after taking this one, the value I'm getting as your 6 6. So 6 6 you can find out. This is your 6 coordinate here, and in this axis 6 coordinate is here somewhere. Okay, so this is the new cluster center, updated cluster center. Similarly, the cluster center of this one you can find out easily. A2 and A7 average, you can see it here also. So A2, 2 is here and 1 is here. So 2 plus 1 by 2, and here 5 plus 2 by 2. Okay, so that becomes your 3 by 2, that becomes your 1.5, and 7 by 2, that is equals to 3.5. So the updated cluster center is your 1.5 and 3.5. So now again we will be starting our calculation. Same calculation we will be doing, but the cluster centers has been changed. Okay, so here the cluster center is something different. So this is your initial cluster center 2,10 because that is based upon this one, this cluster. Second cluster 1.5, 3.5, and third cluster 6, 6. Okay, same thing. We'll be finding out your Euclidean distance. Euclidean distance of all the data points. Okay, so 2 to 10 means 2 to 10 to 2 to 10 distance, that is equals to 0, and here the distance is 6.52, and here the distance is 5.65. Like that I have to find out all the distance. Okay, and again after finding out all the distance I have to check for the minimum distance. So based upon that I'll be assigning the clusters. Okay, so here you can see minimum distance is this one. So C1 is this one, means it should go to your this cluster C1. Okay. Similarly, minimum distance is 1.5 feet. So that must be assigned to your C2. Okay. So like that, I have to assign all this cluster. So after assigning these things, let us see how the clustering has been changed. Okay. So initially, the cluster was like this. Okay. So this was my first cluster. This was my second cluster. This was my third cluster. So after updating this cluster center and doing all this calculation, so what happened? These are the changes happened here. You can see after this calculation, previously only this point was there in cluster 1, but after this calculation you can see C1 is there, and here C1 was also, means this A8 is also assigned to your C1. Okay, so this point was in C1, and here this has been also added to your C1. Okay, and here you can see this is in its C2 and this is in its C2. So this is in C2. Okay. So this is in one cluster. These 2 points are in another cluster, and rest of the points are in another cluster. Okay. So here you can see same thing. A1 and A2, that is in one cluster right now, and here A2 and A7, that is in one cluster, and rest of the points are in another cluster. Okay. So here now it seems little bit correct, but still we are confused with this point. So what is happening to this point? So uh, again we have to update our cluster center. So here what happens? Again we have to take the average of those cluster points, and we have to find out the new cluster centers. Okay, so new cluster center will be the centroid of these cluster points. So that calculations have been done here. So 3, 9.5 and 6.5, 5.25, like that. Okay, so after finding out this cluster center, again we'll be performing that set of calculation. Okay, so that distance will be finding out. Okay, so the step, the process is very easy. Just you have to find out the distance. Okay, so again we'll be finding out the distance with respect to the new cluster center. You can see it here. Okay, so all these calculations has been performed. So always perform these tabular form calculation. Okay, so after finding out this thing, you can see uh, this point and your A8, they as well as your this point, you can see A4, they have been kept in one cluster. You can see C3, C3 and C3 are there. That means these 3 points have been kept in one cluster. Okay, next these 3 points are kept in another sort of cluster. You can see I have uh, highlighted them using some red color rectangle. Okay, so you can see these 3 points are in another cluster. Okay, similarly A2 and A7, they are A2 and A7, they are in one cluster. Okay, so there is no change in this clustering. Okay, this cluster is unchanged. Only thing that is changing, that is in its this cluster. Okay, so after doing this one, this looks little bit correct. Okay, so after that, whether this is the final clustering or there are some more changes are needed. After that, what happens? We have to perform, and again we have to perform the same step. We'll be repeating the same steps. Okay, again we'll be finding out new cluster centers. So the new cluster centers means this will be based upon these cluster points. So C1 will be centroid of these 3 points, C2 will be centroid of these 3 points, and C3 will be centroid of these 3 points. Okay, so we'll be calculating the centroids of these three clusters, and again we'll be doing same calculation. Okay, so after performing same distance, you can find out there is no change in the clustering. Okay, so same thing we have done. So we'll be just calculating your distance, and based upon the minimum distance we'll be assigning the clusters. Okay, so once we have done this one, completed those calculations, after that we can find there is no change in the clustering. Okay, so so whenever we are finding that there is no change is happening in the clustering, at that time we should understand that our algorithm has converged. Okay, that means this has been completed. There is no need for further steps. Okay, there is no need for updation of your cluster centers. Okay, so you can see previously the clusters were like this. Okay, so these 3 points were kept in one cluster, these 3 points were kept in second cluster, and these 2 points were kept in one cluster. Same thing happens here also. There is no change in the clustering. So at this step we can conclude that there is no changes happening in your clustering, so there is no change. There is no need to update the cluster centers. We can stop our algorithm. So this is the final clustering of these 8 data points or the whole data set. Okay, so here what happens whenever we are finding out this distance. Okay, so suppose you can see, once I have found out this thing, okay, and I have found out my cluster center, I can imagine that it is going to converge at this step. Okay, how I can imagine that? You can see, or we can imagine that from our updated clusters itself. Okay, you can see that what is happening once this thing has been completed. After that, I can find out my updated clusters. So updated cluster centers. So my updated cluster center is 1.5, 3.5 is here. So you can see this cluster center is not changing because we have already seen that there is no change in this case. Okay, so that's why you can see 1.5, 3.5 is not changing. Only 2 points or two cluster centers are changing. But after this step, you can see the cluster centers are not changing significantly. Okay, they are not changing significantly because you can see here 6.5 and 6.5 and 2.25 was your previous cluster center, and after the updation this becomes your 7 and 4.33. So there is no significant changes are there. Similarly, here also 3 and 9.5 was there previously, and here it becomes 3.67 and 9. So there is no significant changes. So at this point, we can imagine that in the further step, our algorithm is going to converge because there is no significant changes are occurring in my cluster center because all the calculations are done with respect to your cluster centers. Okay, so as my cluster centers are not going to change or they are not changing significantly because this is remaining same, only two things are changing and these changes are not so much significant. So that's why my algorithm is going to converge because as you can see these points are not changing, so that's why these values are not going to change so much. Okay, so that's why my clusters are not going to change because the distance values will be more or less same. Okay, or they will be quite close to each other, so that's why these clusters are not going to change. So what happens from these clusters itself, or while updating the cluster centers, you can imagine or you can predict whether your algorithm is going to converge or not. Okay, so this is the whole process of clustering. Okay, so at least you have to perform 3 or 4 steps to find out the final clustering. Okay, so whenever you are finding out that there is no change in the clustering is happening, okay, or you can say that your clusters are not changing anymore, at that time you can stop. Okay, so here you can see all the calculations what I have told you or what I have done, that is based upon your Euclidean distance. Okay, you can try the same problem based upon your rectilinear distance also. Okay, so if you are following rectilinear distance, then what happens? Okay, rectilinear distance means this using this formula. Okay, that is actually that is not used. Okay, but you can still check because sometimes to if the calculation process is very lengthy, or you can say if the data set is very huge, at that time these types of formula may be used. Okay, you can check what happens if you are using this formula for calculation of distance. Okay, process is same. Only thing you have to find out the distance using that rectilinear formula. Okay, instead of taking the sum of the square and root over of the whole thing, you'll be just taking the sum of the absolute difference. Okay, between the points. So you can check what how much iteration it takes to converge the algorithm, or how much your clustering differs from differs between these two process. Okay, so this is the example of your clustering. I hope all of you have understood. Okay, I'll be posting this in your meetup also. Please go through this example. Uh, and from this example, you can understand what is written here, okay, in this algorithm. Okay, so first we have to decide your number of clusters. After that, we have to choose your initial cluster center locations. So I have already told you, you can pick some points from the data itself, or you can choose some data which are not in the data set. Okay, those are just assumptions, and based upon that initial cluster center, we'll be finding out the distance. Okay, and based upon the minimum distance, we'll be assigning the clusters. Okay, once we have formed the clusters, after that we'll be updating their cluster centers, and the cluster centers will be the centroid of the data points inside each cluster. And based upon that cluster center, we'll be finding out the distance. Again, we'll be updating the cluster center. That step will be continued. As you can see, repeat 3 to 5 until your algorithm converges. That means until your algorithm doesn't change, or until your clustering doesn't change. So that thing is written. So how to find, basically you can see step 3, the nearest criterion. Okay, so the how you're going to find out the nearest criterion, that is based upon your Euclidean distance, means minimum value of your minimum value of your Euclidean distance. Okay, and although other criteria may be applied as well, means you can use also the other formula, but usually those are not used. So how you are going to update the cluster centers? Just by taking the center. Okay, so here you can see one example is given. Suppose these are the points inside the clusters. Okay, so suppose 111, 121, 131, 211. Then what will be the new cluster center? Just take the average of this one. So 1 plus 1 plus 1 plus 2 by 4. That will be your 1.25. Similarly, 1 plus 2 plus 3 plus 1 by 4, that will be 1.75. Similarly, 1 plus 1 plus 1 plus 1 by 4, that is equals to 1. So this will be my updated cluster center. So these processes are going to be these processes are going to be repeated until your clusters doesn't change. Okay, so that thing is that the algorithm terminates when the centroids no longer change. That means your cluster doesn't change. If your cluster is not changing, then your centroid will also not change. Okay, but before that, I have told you, you can just visualize, or you can imagine that my algorithm is going to converge based upon the changes between the points. Okay, if the cluster centers are not going to change significantly, at that time you can also imagine that my algorithm is going to converge in the next 1 or 2 steps. Okay, so this is all about your uh, this is all about your clustering, or K-means clustering algorithm.